Good afternoon. Welcome to Foundations of Pharmacology. I'm Dr. Lori Taylor, and we're going to be talking about dimensional analysis today. I know that some of you have studied dimensional analysis in the past in another class, but please just try to think about what we're doing here today, because if you studied it in chemistry or in math, it's going to be a little bit different. So let's start out with talking about our goals for the class today. Our goals are to introduce the concepts of dimensional analysis and to equip you, the learners, to begin using this method to calculate safe dosages. I know you've been talking a lot about in your foundationals class about how important it is to know how to calculate medications and how to give those safely and to care for our patients safely. So this is a really important topic. The objectives for today's class are that by the end of class, you as the learners will be able to list the 3 rules of dimensional analysis that we're going to cover, that you'll be able to define the components of the acronym WACO, that you'll be able to demonstrate the ability to evaluate the components of a given problem considering this acronym WACO, that you will be able to demonstrate the ability to apply the 3 rules of dimensional analysis, and that you will be able to demonstrate the ability to apply the acronym WACO as a guide for dimensional analysis structure. Okay, so how are we going to use this strange word? I know this is a city in Texas, but today it's a way that's going to keep us on track when we're calculating medications safely. Let's start out by defining what each of these letters means. W stands for want. When you're deciding what you want to start your dimensional analysis with, you want to think, what do I want to take to my patient? And in order to know that, you have to know what form that medication comes in. You also have to keep in mind that what you want is something that you can measure. And I have some examples for you. On this slide, which I know each of you have, and it's loaded onto Canvas, here are pictures of things that you're going to use as the things that you want. These are things that you can actually count, that you can actually measure at the nurse's station, like tablets and caplets and suppositories, oh my! Or like the inches or centimeters when we use NitroBid, or a gallon of milk. No, you wouldn't take a gallon of milk, but you might take a gallon of Go Lightly for a colonoscopy prep. Milliliters is something else that we use quite often, and all of the different household measurements as well. Units we see on here too. I know you've talked about that in other classes. We use units to measure insulin and heparin and some other medications. Now, just as these are the medications that are okay to use in that want slot for your dimensional analysis, there are some that are not okay. And I'll tell you why I did this slide this way. I've got some people in my family who are law enforcement. And so when I think of some of these forms of medication, kilograms and grams and milligrams and micrograms, I think of drug dealers. And you cannot want the drug dealers. Just say no. The A in WACO stands for available, and that's the concentration that you have available there to actually take to your patient. Whereas your want was a single thing, a single form, the available is both the form from the want plus the amount of medication that's contained in that form. So this is, we would look at what the pharmacy sent up to the floor or what you have in the medication cabinet in your clinic. This is going to include a top and a bottom entry. The top is going to be the same as the want. The bottom is going to be something like milligrams or micrograms or grams. Let's look at this in a real life situation. So from looking at this and from what you've heard so far, what is the form that you would want to take to your patient? The nurse practitioner ordered that the patient receive 1/2 gram of penicillin VK, POBID. looking at this bottle, what form are you going to take? You're right, tablets. We see that there are tablets in this bottle, and each of those tablets have 250 milligrams contained in them. So the form that we have available is both tablets and 250 milligrams. The next letter is C, and that stands for conversion. The first question on here says, do I need a conversion? And that kind of tells us sometimes we do and sometimes we don't. What a conversion is those things in chapter 3. I know you've all been reading in your Nurse Math and Meds by Mulholland and Turner. I know that you have been working on learning the conversions. Those are the conversions that we need to make the available form that we have to give our patient match the order form that the provider has ordered. This entry also, it's okay to use the micrograms, the milligrams, and the kilograms. All of those that you cannot use in the want section. Okay, so let's look at this and decide, do we need a conversion? Same problem that we read before. We've got our want at tablets. We've got the available as tablets and 250 milligrams. And then do we need a conversion? Do we? Right, we do, yes. Because the provider ordered half a gram and we have milligrams, we're going to have to add a conversion entry into our dimensional analysis. And I'm going to show you how that looks in just a minute. Good, sounds like you're getting it. The O stands for order, and the order is just exactly what the provider ordered. No different. All right, so I've included this in the PowerPoint so that you can look back later on. And this is the whole formula here, the whole dimensional analysis problem is on the PowerPoint, but I'm going to write it on the board so that we can work this out together. And we're going to start talking about the 3 rules that go along with this. So if we can remember right, the provider ordered half a gram, and that's the order. And what we have available is 1 tab with 250 milligrams in it. So what is it that we want to put in our want spot? Right, tablets. So tablets is what we're looking for. How many tablets to take into our patient? This takes us to the first rule of dimensional analysis. And that is that whatever's in the want spot goes on the top of the available spot. And this is going to keep you from doing things upside down and backwards if you'll remember these rules. Rules are really important. All right, so to put the available in there, we know that here, 1 tab has 250 milligrams in it, correct? And now we have to think, do we need a conversion? We see the C there. Do we need a conversion? We've already decided that yes, because we're going from grams to milligrams. So this takes us to the next rule of dimensional analysis, which is that after you get this first entry done, whatever's in the bottom goes on the top. And this is going to keep you from doing it upside down and backwards as well. So before I even put my conversion in, I'm going to put my form on the top here from being on the bottom here. So what conversion, if we're going to match milligrams and grams, those of you who've been diligent to study this, what's that going to look like? Right, 1,000 milligrams is going to equal 1 gram, all right? And then each time, we're going to follow that second rule of dimensional analysis every time we make an entry. So what we're going to do is we've got grams here, we're going to put grams up here. We're looking for the order, so what does that look like? Right? 0.5 grams is our order. Do we have anything to go with it? Like we had to go with the 1 tab and the 250? No, there's nothing else to go with it. So we're going to use a 1 as a placeholder. All right, so the third rule of dimensional analysis is that when you think you're done, you cross-cancel to check. Do we think we're done? I do. So we're going to cross-cancel. This is how we do it. Grams cancel out grams, milligrams cancel out milligrams, and we've got tabs left. We look at what we've got left, and if that's the same thing that we have over here, then we're good to go. We've checked ourselves. Now all that's left to do is the math. We're going to multiply 1 times 1,000 times 0.5 and get 500. I'm going to do the same thing on the bottom. 250 times 1 times 1 is going to equal 250. We're going to reduce that fraction by saying 500 divided by 250. And we end up with 2. And the last thing that you need to know to do is always whatever you started with in your want goes down here. All right, so we're going to give that patient 2 tabs. Let's really quick make up another problem and see how you do on it. All right, let's say that we've got an order for 10 milligrams of a certain medication. We have available a vial that contains 1 milligram per milliliter. Pretty easy. We're going to look for our want. What is it that we want to take into our patient? Do we want to take milligrams? No, 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 no. We want to take milliliters. So remembering our first rule, we put milliliters here. And we look for our available. Our available is right here. And it's 1 milliliter. Even though we often see the milligrams first, we know we've got to put it this way because of our rules. 1 milliliter, 1 milligram. Do we need a conversion for this one? Milligrams, milligrams? We don't need a conversion for this one. So for this case, I'm going to change that C into an O, and we're just going to have our order. I'm going to follow my second rule, put milligrams up here for my order. And we have 10 milligrams ordered. I don't have anything else to go with that. And so I'm going to put a 1 for a placeholder. I think I'm done. It looks pretty simple, but I think I'm done, so I'm going to cross cancel. Milligrams, milligrams. What I have left is milliliters. Yay, that matches, so we're good. I'm going to do my math. 1 times 10 is 10. 1 times 1 is 1. That's going to equal 10 milliliters, and that's how much I'm going to take my patient. Okay, I know that you all have the worksheets because I've posted them on Canvas. Let's get busy working on those. You're welcome to talk amongst yourself and let me know if I can help you with anything. Thank you very much.